Hello, I'm going to demonstrate the Scale Computing Ansible Collection for HyperCore and show how you can use it to manage and deploy a fleet of applications across many locations and environments using Ansible. So what you can see here, first of all, let me show this is the results, the recap of my last playbook run. It shows all the clusters that were applied in this run. Everything is green, which means all, as of this point, all sites, all clusters are set up in their desired configuration. So we're going to make some changes, and then we're going to go ahead and walk through the playbook while we run the playbook again. So let me first shut down these VMs. So let's also go ahead and let's shut down one over here. And let's delete a couple things. Let's delete this template. And let's delete point of sale VM over here. So I've now made changes on two different clusters that would take this playbook out of compliance. I'm going to go ahead and kick it off. The command would be Ansible playbook and then the playbook that I want to run. Let's kick this off. In this case, I've got a main playbook here called fleet config. And really all it does is import a bunch of more specific playbooks that you can see here. There's one playbook that manages the template, one playbook that manages the pharmacy VMs, one for the point of sale security, and then a clean up old VMs. But I could have other things in here to do, for example, cluster configuration, like I do have a play that's not in here at this point that would configure snapshot schedules on the clusters, things like that. All those types of things are available through the Ansible collection for HyperCore. So while this is running, we can see already it's gotten to the point where it's importing the virtual machine that we deleted on this particular task. So let's actually look into some of these playbooks here. So first of all, let's take a quick look at the inventory. So the inventory file, this has all of the hosts, all of the clusters in this case that I want to operate against. It's just the DNS name or IP address that I can connect to. These are also structured into groups. So I have an edge group for all of my edge locations. I have a staging group if I wanted to be able to execute the playbooks against just one of those. It's a very easy command to say filter and limit the playbook execution to just that while I'm doing testing. I have different regions, and it is considered best practice to split the metadata and parameters and variables out. So you can say, example, here is a bunch of region 1 variables as an example. This is more I can specify my local SMB path, things like that, a local syslog server, so on and so forth. I did kind of model to maybe I have franchise stores and I have corporate stores. I could have different parameters there as well. So this is just an example of how you can use, and then you can have host specific variables. This is actually right now where I store credentials, which should use Ansible Vault versus here, but we're just using standard credentials here. Things like the site name, if I wanted to be able to apply those into the virtual machine names like we're doing here. If I wanted to have a specific assigned point of sale VM address, I could put that as a variable. And then in this playbook actually does take that point of sale address, and when it provisions the point of sale VM, applies that static IP address there. So you can put all this kind of metadata into here. So let's take a look at this point of sale virtual machine. So really all it does is actually call a role. And so I've split most of the heavy lifting out into roles for a bunch of reasons. One, it could be reusable if I wanted multiple point of sale VMs, things like that. And also if I wanted to have other things, but kind of the main aspects within a role, it's just a little mini playbook here. And you can see the tasks that it's running. And this is kind of the standard pattern for most of these virtual machines. They first check, they use the VM clone module, which can be used to create or verify that the VM is there. If the VM is not there, it will clone it, and it's got all the information to name it, past cloud config information, the source VM that it's going to use. So we won't go into cloud init here, but you can basically configure just about anything inside the VM on first run, from installing packages, running commands, obviously setting credentials, installing SSH keys, setting static IP. So this example is where I use that point of sale address to configure the virtual NIC inside the VM with that specific address. I give it a specific host name, on and on and on. So if the VM is already configured, it can skip that, but then it does check various attributes of the VM to make sure they're in compliance. And this is also where I could make changes over time. So first thing this one does is check the VM name for disk configuration. So it should have one VirtIO disk in slot 0, 300 gig, and should have tiering priority factor set to 1. If I wanted to change that across the fleet, I can make this change, rerun the playbook, and the collection knows all the steps of how to make whatever changes required are necessary. So I can add disks, so on and so forth. The next step here is the VM configuration. So here it's looking, the VM needs to have 1 GB of RAM. It needs to have this particular description. This is assigning a snapshot schedule for this VM. If somebody went in and deleted the snapshot schedule from the VM or changed it, and I ran this playbook again, it would correct it. That's the whole goal of this, is that this is the source of truth for the virtual machine. And then, of course, it needs to be running and with 4 virtual CPUs. I did want to show the template. So the workload VMs are all pretty much along the same concept. Let's look at the roles for the templates. This is where so it will first import the virtual machine if it's not there. So it uses the VM import module, uses the variables for where to access that particular VM. And then it does a little trick here to protect the template, gives it particular attributes so that I know it's a Cloud Init template, and it sets the virtual CPUs to 0 so that it can't be accidentally started. So for example, if I go into this template and I try to power it on, it's going to give an error because there's no virtual CPUs and it's not allowed to run with no virtual CPUs. So there's no way that somebody can accidentally corrupt a Windows sysprepped image, or in this case, my cloud template. So just a little trick there. And then after it deploys or checks all the VM configuration, it goes through, and I have some cleanup stuff of, in various iterations of my old demo, VM demo names. And if they happen to still exist, it would delete them. You would see a change. In this case, they're all green because this has been run and all that cleanup's already been done. So you can see in this case, we only have changes on the 2 clusters that we created intentionally. And that's as designed. And if we were to run, this playbook again, it is fully idempotent. We'd have everything come back and see everything green in this particular case. This could be scheduled. There's also another mode. This particular playbook is not set up to work this way, but there's a mode of using Ansible called Ansible pull. So instead of Ansible playbook command, it's an Ansible pull command, which can go right to the GitHub repo. And again, I would need to make some changes because of some differences in the way Ansible pull operates. But Ansible pull, you could have each cluster with some sort of a runner pull its configuration with a schedule job and apply these changes autonomously. That would be a great configuration. Say if I had ocean-going vessels that all connect in at different times, they could be checking, and when they do have connectivity, when they're at port or in a good satellite zone, they could run the Ansible pull, get any changes to their desired configuration, apply those and execute those autonomously. So there's, again, a lot of different ways of using Ansible. And then another key aspect here that I mentioned but aren't showing at this point is the ability for Ansible to call other things. So we created the Ansible collection to be able to control the HyperCore aspects, but there's already a wide ecosystem of modules that can configure various applications on Linux and Windows, handle networking, gather data. It would be very easy if I wanted to, in my role here for the point of sale VM, for example, do some tests, ping something, connect to a port, run a little sample query, all those kinds of things to verify that my application is running correctly. Those would be pretty easy to add to this playbook into that particular role, or adding some other kind of test function. So a whole lot of capabilities that can exist here and are enabled by this kind of fleet-wide automation and very scalable process. So thanks, and feel free to check out my GitHub repo that has these artifacts and add any suggestions or comments, or leverage them and build your own playbooks. Thanks.